Hi guys, welcome back. I'm just going to have you quick look at the answers from your worksheet to see if they match my answer key. Tomorrow you'll have a chance to ask me any questions that you have. Go ahead and just pause me if you need more time. And also show you problems 4 through 10 right here. And you know what? Don't copy down my answers. It's more important that you would just check what you've done. You have an extra day now to go back and figure these things out. Let's look at the back side. You'll see that I drew my 45, 45, 90, and 30, 60, 90. 1, 1, square root of 2. 1, 2, square root of 3. And then I just did my SOHCAHTOA off of that, making sure to rationalize my denominators. Number 18 through 21 was sort of a review of what you learned in geometry. So if you struggled with that, may I suggest hitting up YouTube and typing in 30, 60, 90, 45, 45, 90 just to review those things. You'll be glad you did. Today's lesson we're talking about a new type of angle measure called radian measure. So even if you're gone on Friday, you're going to do great on this because we're just talking about angles today. You know that we measure angles in degrees. So typically we would take an angle like this, and maybe that's a 60-degree angle, right? We're just going to talk about that in a little different terms today. Let's talk about this circle. And so if I were to label this radius R, obviously this would still be R. So maybe that's 10. Maybe that's 10. And you should be able to travel that same distance around the circle, like 10. So if we were able to find a curvy distance that was the same as these two radii, there's actually something special about this angle, right? And so that's why they decided to make a new sort of system, kind of like the metric system for measuring angles, where this angle is important, and this angle is called 1 radian. Okay, and it just so happens it doesn't matter what the radius is. If the radius was 5, and I traveled a distance of 5, I'd get that same angle. If I traveled, like I said, 10, and traveled a curvy distance of 10, that would be the same angle. And so there's something special about that. And so we're going to talk about radians today. Radians is what we're going to use instead of degrees sometimes. So I just want to show you this. If we measured 1 radian out here, and we measured another radian, and we measured another radian, we would get almost 1, 2, 3 radians by the time we got all the way to, what's this, a straight line, so 180 degrees. So there's a little more than 3 radians that would be equal to 180 degrees. And what's our favorite number that's a little more than 3? That would be, I'll give you a hint, this is about 0.14 radians right here, this angle right here. It turns out that 180 degrees is the same thing as pi radians. So we're just going to write that down. That's kind of our important reference for today. 180 degrees is the same thing as 1, 2, 3, and a little bit more pi radians. And there's a reason I put that in parentheses, because technically radians doesn't have a label like degrees does. Yeah, so what would happen if we took 180 and split it into a little more than 3 parts? What would 180 divided by pi equal? My calculator is telling me it's about 57.3. And so that means that each of these little angles right here is about 57.3 degrees. So we could say that 1 radian is about the same as a 57 degrees. That's not really a huge deal, but I just want you to understand that a radian is just another way to measure an angle. So let's talk about some of the special angles we have in our lives. And we just talked about a straight line angle. 180 degrees is the same thing as pi radians. So that this angle, you could either label it 180 degrees, or you could label it pi for radians. So if we only went half the way to 180 degrees, that would be 90 degrees. And what's half the way to pi? Pi divided by 2. So we call that pi over 2 radians is the same thing as 90 degrees. We can measure all kinds of angles. If we went 90 plus 90 plus 90 and went all the way out to here, 90 plus 90 plus 90 is 270 degrees. And if we're thinking radians, we're thinking, okay, well, we had a half a pi, another half a pi, another half a pi. That's 3 half pi's, or 3 pi over 2's. Or you could think of that as 1.5 pi, because that's 1 pi plus another half pi. So anyway, 270 degrees is 3 pi over 2. And if we were to go all the way around the circle, 90 plus 90 plus 90 plus 90, 180 plus 180, we would get 360 degrees. And in radian language, that's 1 whole pi plus another pi. So that's the same thing as 2 pi radians. Okay, which is a little weird because you would think a whole circle should be like a pie, like you eat, but a half circle, a 180 is pi radians, the whole circle is 2 pi radians. We're just going to talk about some different ways that we can split up our 360 now. And actually I'm going to talk about more like splitting up our 180. So let's take our 180 up here and we're going to split it into fourths. So we can split it in half and then split it into fourths. And if we take 180 and split that into fourths, that's the same thing as 45-degree angles. So each of these is a 45-degree angle, right? Okay, so if we're thinking radians, we just took our 180 degrees, which is pi, and we split that into 4 pieces. And so really, we're just going to call a 45-degree angle, we're going to call that a pi over 4 angle. Okay? And so we could measure 2 45 degrees as 2 pi over 4s, right? 2 pi over 4s would actually reduce to pi over 2, which we just talked about, that would be 90 degrees. So this is our 45 degrees. This would be 90. If we added another 45, would be up to 135. So how can we look at that in a radian measure? That would be a pi over 4 plus a pi over 4 plus a pi over 4. And so that, I guess, would be 3 pi over 4, or 0.75 pi. 3/4 of the way to 180 degrees is 135 degrees. And again, if we counted 1, 2, 3, 4 pi over 4s, can you see what's happening? 4 pi over 4s is the same thing as pi. That's our 180 degrees, right? So anytime you see something split into divided by 4, it's talking about some sort of multiple of 45 degrees. We're going to do that again with thirds. This is a little harder to draw, so do your best. So we're going to take the top half of the circle and split it into thirds, which maybe would look something like this. So can you see those 3 angles in there? One of them would be right here. Another one actually spans over that y-axis. And then here's our third one. If we're thinking in degrees, we're taking 180 degrees and splitting into 3 sections. That's 60 degrees each. 60 plus 60 plus 60 is 180. But when we're talking about radians, we're going to talk about pi, because 180 is the same thing as pi in radians. We're going to take pi divided by 3. So if I'm talking about radians, this angle, not 60 degrees anymore, it's pi over 3. And if I wanted to do 2 of those, 2 60-degree angles, it would be 2 pi over 3. I could go 3 pi over 3, which usually I would probably reduce that. And I could actually keep going. We could keep going all the way around the circle if we split the bottom half into thirds, right? If we come from here, 1, 2, 3, 4. If we come all the way here, this is 4 pi over 3, which is over 180 degrees. If we make it all the way to this spoke, we'd be 1, 2, 3, 4, 5 pi over 3. Sometimes you'll see people putting their label on the outside of the circle. They're still talking about the angle, but it's just easier to label like that. So we'd have 1, 2, 3, 5 pi over 3. And then if we made it all the way around, we split our entire circle into 6 pieces. So if we went all the way around, we'd be at 6 pi over 3, which reduces to 2 pi. So that entire 2 pi circle split into thirds would be increments of 60. So pi over 3, 60 degrees. 2 pi over 3s, 120. 3 pi over 3s, which usually you'll have reduced to pi, is 180 degrees. And you can keep going. We could add another 60 to that, right? Add another 60, add another 60. And the last one that you're going to see pretty commonly is splitting into 6. So let's take the top half of the circle, split into, so you're going to take each sort of quadrant and split into thirds. 1, 2, 3, 4, 5, 6. So that's our top half of the circle, 180 degrees, divided into sixths, which is 30 degrees each. So when we're talking radians, instead of saying 30 degrees, we're going to say pi divided by 6 radians. Pi over 6 radians is the same thing as 30 degrees. 2 pi over 6 would be 2 30s. 3 pi over 6 would be 3 30s. 4 pi over 6, 120. You kind of seeing how this works? This reduces to pi over 3, which actually we just talked about, right? 60 degrees is that top half of the circle split into thirds. 3 pi over 6 is actually just pi split in half, which is 90 degrees. And this is 2 pi over 3, which we also saw as a multiple of 60 on the last page. So that's how I want you to think of radians. Now, there is a conversion factor, since we know that pi radians is equal to 180 degrees. We can get all technical and say that if we're converting from radians to degrees, we could just multiply by 180 over pi. Sometimes that's useful. Sometimes it's probably just quicker to think of how much would 280 degree angles be. That would be 360 degrees. But if you want to use the conversion factor, here's how it works. You would take 2 pi and multiply by 180 over pi. And that'd be 2 pi over 1. So what would you get? You'd get 360 pi on the top. 1 times pi is pi on the bottom. Pi divided by pi is going to just be 1. So you get 360. 3 pi over 5, you could either think of that as taking your 180, splitting into 5 pieces, and then taking 3 of those. Or we could use our conversion factor. Sometimes it's easier just to not even multiply those, because you can see that those pi's should cancel out, right? Pi divided by pi is 1. And maybe we can just reduce, like I said, if you're going to take the 180 and split it into fifths, each of them would be 36 degrees. And then we're taking 3 times 36 is 108. So 108 degrees is the same thing as pi split into fifths and taking 3 of them. So we can see that our pi over pi is 1. This time maybe we could take our 180 divided by 4. And we've done that before. 180 split into fourths is 45 degrees each. And if we take 5 45s, that's going to be 225 degrees. 225. We talked about 1 before. If you take it times 180 over pi. Now this time the pi's don't cancel out. So you could write your answer like this, 180 divided by pi. That's how many degrees are in a radian. or we could just reduce that. 180 divided by pi is approximately, remember seeing this number before? 57.3 degrees. 3 of those, 3 radians. Well, that's a little less than pi radians, right? 3.14 would be 180 degrees. 3 would be a little less than that, so let's see what that comes out to. So this is going to be whatever 3 times 180 is, divided by pi. Let's calculator that up. I thought it would be almost 180, and I just got 171.9. You can do this backwards to go from degrees to radians. You're going to have a conversion factor of pi over 180. I probably should have put the degrees on there because it kind of makes sense. We want to cancel out the degree units with some degree units on the bottom, leaving ourselves with radian units. So we've got 50 pi over 180. If you can just reduce that 50 over 180, comes out to 5 over 18. If you divide both of them by 10, I think that's as far down as it can go. 5 pi over 18 would be your radian measure for 50 degrees. 5/18 of the pi. 80 degrees. We're going to see pi show up here because the pi doesn't cancel, the degrees cancel. And we can cut that down by 10. We've got 8 pi over 18. And if I guess we can half those, right? 4 pi over 9. 150, we've seen this one before. But if you don't recognize it, we can always go this way. So our degrees cancel out. We've got, well, if we divide them both by 10, 15 pi over 18. What, divide by 3? 5 pi over 6. Remember, pi over 6 is like taking 180 divided by 6. That's a 30-degree angle. And what do you get if you take 5 30-degree angles? 150 degrees. So really, this is all connected. It all makes sense. This is just sort of a shortcut conversion for us. Try another one. So we've got 315 pi over 180. I'm pretty sure I can get a 5 out of both of those, right? Okay, I've got 63 pi over 36. Cut those down by 9. Is that going to work? 7 pi over 4. Pi over 4 was our 45-degree angle. 45 times 7. I'm just checking to make sure this makes sense. So I got 315 degrees, which makes sense to me. And then 270, I kind of remember that one, because that's 390s, right? Would make 270. So the degrees cancel out. Divide both by 10. Divide both by 9. 3 pi over 2. That's why I remembered that one, because pi over 2 is the same thing as 90 degrees. 180 divided by 2 is 90 degrees. So I've got a pi over 2 right here, and I want 3 of them. Take that times 3, and that's where that 270 came from. I'm just hoping that this sort of makes sense. It's a kind of an awkward way to write angles, but now you'll understand the clock that's hanging up on the wall over there. That's what it's labeled in. It's labeled in radians. Tomorrow, we're going to talk about lots more angles. We're going to mix together our degrees and radians. For today, I just wanted you to understand what a radian is.